Joining us today is Mark Sale, the CEO of First Class Metals, where today we're going to get a project overview of the ESSA block, which is part of First Class Metals' portfolio in the Schreiber-Hemlo region of Ontario. So thank you very much for joining me again, Mark. We're going to talk about the ESSA block, and maybe you can just start us off by giving us the high-level overview of this project.
Certainly, Mark. Thank you for hosting me again. Yeah, the ESSA block, it's 86 claims, 20 square kilometres. It's a sizable chunk of property, but its situation 10 kilometres north of the Hemlo gold mine and almost touching our North Hemlo property, flagship property, is a critical location. And it's important not only spatially, geographically, that it's close to Hemlo gold mine, but also geologically, because it has a shear that runs through the centre of the property. And I'll dwell a little bit more on the significance of that, if you'd like, Mark.
Yes, please. I think you've mentioned these shear zones a couple of times, and there is a picture we can see here where it looks like 3 shear zones. So I wonder if, just bearing that picture in mind that we'll also put up here, maybe you can just take us through that.
Yes. Okay. Well, the Hemlo, the 23 million ounce Hemlo gold mine is enigmatic, and there's lots of sort of discussions as to its genesis. However, the one thing that you can't argue is that it's a shear hosted gold deposit. Okay. Now then, there are identified by other companies, not by First Class Metals, so we're not tweaking the evidence to suit ourselves, shall we say. Mm-hmm. There are 3 further shears to the north of the Hemlo shear, and 2 of them, as I mentioned yesterday, go through our North Hemlo property, and the one immediately north of Hemlo goes through the centre of our ESSA property. So we have a shear transecting the property. This shear was identified by our neighbours to the west. So this comes back to the nearology and the vectors that I've been going on about with the First Class Metal properties potential. And not only is this shear identified on the western boundary, but very close to our boundary, the Barbara Lake occurrence actually has 2 grams of gold in it, almost smack bang where you would infer the ground trace of the shear. Now, on our ESSA property, one of the reasons I believe there's been a lack of historic exploration is because there is very little outcrop that we've come across so far. There's a lot of glacial cover, and it was quite heavily forested until recently, and the logging activities have certainly increased our accessibility, which is good. But anyway, point is, not a lot of outcrop. So this shear was never really identified on the ground in order to be prospected. We recently, at no charge, managed to acquire this survey over ESSA, which we're currently having reprocessed and interpreted, which we hope will tie down the exact location of that shear on the ground, so we can get in there and prospect it. And once we have an exploration permit, probably follow that up with trenching as well. Importantly, not only on the west is it anomalous, but on the eastern boundary, on the adjacent property, there are several reported anomalous gold values. So we have all the recipe, shall we say. We have a shear. It's identified as transecting our property. It's real because our neighbours have identified it, and it shows up on the geophysics, and geochemically, it's anomalous. So now we just need to get in there and find a bit of geology to prove it up.
Indeed. Okay, so as you say, they weren't identified before these shear zones because there's very little outcrop, but you're very certain that the shear zone is there based on research that your neighbours have done and what you're seeing from surveys you've done. Is that right?
That's correct. I mean, the photo or the figure that you've got there of the magnetics over ESSA, that's the government magnetics, and it's quite coarse, shall we say. But the data that we have acquired not only has magnetics, but it also has EM. That's the EM is the EM in V10. So we have Magnetics, which will help us identify structures, which is really important with gold deposits, obviously, hence the shear. But the EM part of it might also help us identify conductors, which can be, in the best interpretation, solid sulfides, nickel, copper, etc. So the VTEM that we've got for ESSA is critically important in us tying it down on the ground as to where it is. But it's not only that shear that dissects the property that is critical in its potential. For me, also on the southern border of the property, just inside our boundary for the most part, is the contact with the Cedar Lake Pluton. And plutons are big, hot blobs of granitic rock coming up from deeper in the crust, slowly rising like those old lava lamps that our parents would have had back in the 50s or 60s, whenever they were vogue. And this granitic pluton comes up and causes a lot of disruption. It's creating a lot of hot water, which is leaching the minerals, the elements out of the rock. And then when you get the fractures, that hot water is entering those fractures, changing temperature, changing pressure, and it's precipitating the metals out of the water. So that Cedar Lake Pluton in the south is also a veritable exploration target for us. And I'm hoping that, as I say, this geophysics interpretation will help us tie down exactly where this crosses into our property. So again, we can focus on the ground because, as we've been saying, there's so much ground cover that you won't find outcrops of it, or probably won't find outcrops of it. Mm-hmm. So, yeah, there's a lot to happen at ESSA. There is you'll see a third geophysical structure up in the north west to the southeast of the property, and again, that needs to be prospected. And you might possibly be able to pick up the trace of an almost north-south structure cutting through all three of those features I've previously mentioned, which again, intersecting structures is always a good point to look for potential mineralization. So contained in this 20 square kilometers, there's three, possibly four structures all happening that could be the source of metal enrichment. Very exciting, to be honest.
Well, we can see the mag there overlaid on the map, and how the contours of these shear zones sort of also match with the contours of the mag there. I wonder, before I talk a little bit more about the mag and the potential targets here, a shear zone, could you just explain what that is? Is it like a fault line?
Well, no. A fault is more abrupt, like a break, whereas a shear is more sort of when two rock masses, it can even be the same rock mass has a weakness and they're rubbed against each other, and it's this rubbing. And faults can happen quite quickly in geological time, whereas shears can keep going and be regenerated, reinvigorated. And so you can have multiple events. And it's the joggy openings in this shear that are critical. Those are the ones that create the spaces. But in some ways similar to the mineralization I just mentioned on the edge of the Pluton. It's all about structure. It's about creating open spaces that this hot fluid, potentially bearing minerals, metal minerals, can be deposited into. So shears are slow, long geological events, and they can be actually long features too, of course, covering hundreds of miles. But in this instance, we're talking tens of kilometers. So shears are important. As I say, it's that rubbing against, that opening up of the rock. And you can, as I say, you can have a shear where two rocks are in contact, or you can have a shear in the same rock type. So that it's not necessarily critical what the rock is that hosts the shear. It can be, because obviously the acidity of the rock, the chemical composition of the rock might aid the precipitation of those metal ions. But it's the structure, it's the shear that is the important aspect.
Okay, and this opening up that allows the deposit of potential minerals that of course, you're looking for. So
that's correct.
So how do you go about targeting it then? Looking at this mag here, are we looking here at the darker colours, the red and then the magenta? As I can see, that is on the shear zone, but also, as you mentioned, the Cedar Lake is a prospect as well, and it looks like, again, there's a very reddish, magenta-ish colour there. So is that what we're looking at? Is that a magnetic glow that you'll then use to hone in on targets?
The warm colours are normally the highs, so the lows will be more the blue colours. So it is the red colours that we're looking at as far as the narrow structures are concerned. I mean, the Cedar Lake Pluton looks quite hot, but that will probably be because it's more of a mafic Pluton, so it's got iron-rich minerals in it, as opposed to a felsic, more granite. It's these lines that are the important thing. The lines are indicating that there's magnetic features in lines, in structures, and where they cross, as I say, can be supercritical as well.
Okay. So what stage are you at then in honing in on some targets here?
Well, we've had ground crews out on ESSA, and in fact, we had one out there recently doing some follow-up work. We've sort of tried to preempt a little bit the results from the interp of the VTEM that we have, in so much as we've taken soil samples in north-south lines across where we believe the surface expression of this shear will be. So we're a little bit ahead of the game. We're waiting for those results to come back. Quite long soil lines, obviously, because it's quite a wide feature and we don't know exactly where it is on the ground, so it's a best guess. So we're hoping that those will come back with anomalous values, obviously, and that will allow us to focus in on where the shear is, aided by the definition from the reinterp of the magnetics.
Okay. But you said earlier, I think it looks very, as I said, interesting or exciting. What makes you say that?
Well, partly because we have identified boulders. Now, okay, a boulder is a rock that's not connected to the ground, otherwise, other than just floating in the subsurface. It's not outcrop, in other words. But we have identified boulders that are mafic, which is important as opposed to granitic. They are sheared and they're sulfitic. So we have got the right geology, we've got the geophysical response, and off property but there are identified anomalous gold zone. At this stage, ESSA is more of a gold play than a base metals or battery metals play, but we'll see what the data brings us. Maybe we need to focus on one of these other structures other than the main east-west, shall we say, shear for potential base battery metals.
Okay. And what's your timeline looking like then to get this initial survey work done?
Well, as I say, we've had crews out there finished last week taking these soil lines, but as soon as we get the interp, which I'm hoping will be early September, as soon as we get that back, we will try and free up another field crew and get back in there and tie it down on the ground. I'm actually going out next week to Canada, and one of the things I want to look at is in the southern part of the property, this contact with the Cedar Lake Pluton.
Okay. Excellent. Well, thank you very much, Mark Sale, CEO of First Class Metals, for giving us a bit of an overview there of the ESSA project, and look forward to seeing how things develop there. It certainly seems like there is a early stage exploration work well planned in the diary.
Thank you, Mark.
If you enjoyed this interview, then give us a thumbs up, a like or a retweet. Subscribe to us on YouTube or follow us on Twitter, and hit that notification bell to be the first to know when we release new content. There's loads of great content on our website too, across all our programs at stopboxmedia.com. Thank you for watching.